Hey everyone, welcome to my channel where I talk about AI speech. I'm Deb, and this channel is your go-to space for exploring the fascinating world of speech AI. Whether you're curious about voice assistance, speech recognition, or the future of speech AI, you're in the right place. In today's video, we're diving into a quick but insightful summary of the history of speech technology. We'll explore how we went from clunky machines barely understanding a word to smart systems that can hold conversations, translate languages, and even mimic human voices. So let's rewind the clock and see how speech tech evolved into the AI marvels we use today. In 1939, Bell Labs unveiled the voder, the first machine capable of producing human-like speech. It didn't record or play back voices. Instead, it generated speech sounds from scratch, using tone oscillators for voice sounds and noise generators for unvoiced sounds like s or sh. A highly trained operator sat at a special console pressing keys to select vowel formants and consonant sounds, while foot pedals controlled pitch and inflection. By skillfully combining these controls, the operator could play speech in real time, creating complete words and sentences. It was a marvel of electromechanical engineering and the first time in history that a machine truly spoke. Moving forward to 1952, Bell Labs built Audrey, a machine that could recognize the spoken digits 0 through 9. It worked by analyzing the basic shapes of sound waves and matching them to stored templates. No deep learning, no AI, just clever engineering. A decade later, in 1962, IBM introduced the shoebox, which could understand 16 English words and perform basic arithmetic. It used rudimentary electronics to compare speech patterns to a preset library of sounds. These were pattern matching systems, amazing for their time, but still far from true artificial intelligence. By the 1970s, speech recognition took a big leap forward with the use of phonemes, the smallest building blocks of sound in language. Instead of trying to recognize whole words at once, systems broke speech down into these tiny sound units, making recognition more flexible and accurate. These rule-based models use sets of linguistic rules and dictionaries to piece phonemes together into words and sentences. This approach laid the groundwork for the first practical applications, like the phone-based voice menus that started appearing in the 1980s, where you could say simple commands to navigate automated systems. The big breakthrough came with hidden Markov models, or HMMs. Unlike earlier systems that used fixed, hand-coded rules, HMMs learned from actual speech data by calculating probabilities of sound sequences. This statistical learning allowed computers to understand a much larger vocabulary with greater accuracy, adapting better to natural variations in the way we speak. Early text-to-speech systems sounded robotic and monotone because they generated speech from simple rule-based algorithms that didn't capture natural voice nuances. But by the late 1990s, a big improvement came with concatenative synthesis. This technique works by stitching together small recorded pieces of actual human speech, like syllables or words, to form complete sentences. Because these pieces came from real voices, the output sounds much more natural and fluid. That's why concatenative synthesis became popular in devices like GPS navigation systems and screen readers, making computer voices easier to understand and less robotic. Around 2014, deep neural networks revolutionized text-to-speech technology. Models like Microsoft's WaveNet-style architectures moved beyond stitching together pre-recorded clips and instead generated speech sample by sample, predicting each tiny slice of the audio waveform in sequence. This method captured subtle nuances like tone, pacing, and emotional inflection, resulting in voices that sounded far more lifelike. Trained on massive data sets of human speech, these models learned the intricate patterns that make voices sound real, from the timing between syllables to the natural rise and fall of pitch, marking a true turning point where synthetic voices began to truly resemble human ones. One of the biggest shifts in speech technology came when it moved to the cloud, removing the need for developers to build massive models from scratch. With cloud platforms like Microsoft's Azure, powerful APIs for speech recognition, text-to-speech, and real-time translation became easily accessible. These APIs run advanced neural networks on large-scale server clusters, handling all the complex processing in the background. This allows applications to convert speech to text, generate lifelike voices, or translate instantly with just a few lines of code. The result is that high-quality speech AI is now within the reach of everyone, from developers to small startups to global enterprises, powering innovations in customer service, gaming, accessibility, and more. Today, AI speech has gone beyond just converting words to audio. It's truly multimodal. That means it can process multiple types of input at once: the words you say, the emotion in your voice, and even the movement of your lips. Under the hood, advanced neural networks combine audio analysis, natural language understanding, and computer vision to interpret not just what you're saying, but how you're saying it. This opens the door to some incredible capabilities: real time translation that matches your tone, personalized synthetic voices that sound just like you, and AI avatars that speak naturally while syncing their facial expressions and lip movements to your speech. It's the kind of technology that's making virtual interactions feel almost human. Speech AI is moving towards systems that can adapt seamlessly to context, preserve cultural nuance, and support low resource languages. Instead of just translating words, these models can understand the intent behind them, the social and cultural meaning, and the tone that fits the situation. Advances in multilingual large language models and speech synthesis allows them to capture idioms, humor, and local expressions that traditional translation often missed. Techniques like transfer learning and zero-shot training make it possible to deliver high-quality speech recognition and generation, even for languages with limited training data. The ultimate goal is barrier-free global communication, where anyone, anywhere can speak naturally in their own language and be understood clearly and authentically by someone across the world. Speech technology has always been about more than just getting machines to talk. It's about creating systems that can truly listen, understand, and connect with people. From recognizing the words we speak to interpreting tone, intent, and emotion, the real power of speech AI lies in making communication feel natural and human. With generative AI, this will go even further. These models will not only respond, but create generating speech that is personalized in style, emotion, and delivery, adapting in real time to the context and the listener. They'll enable dynamic storytelling, lifelike conversational agents, and voices that can shift seamlessly between language and cultural nuances. While we've made incredible progress, we're still just getting started, and generative AI is poised to redefine how humans and machines communicate. If you like this video and want to see more, please make sure you like and subscribe. See you next time.